Hi, my name is Melanie, and I'm a third year chemistry major, and I'll be working with Magna, a third year biochem major. Today we will work on problem number 6 in chapter 4.2 of the general chemistry workbook. So the problem reads, a 50 milliliter sample of a 0.25 molar solution of ammonium carbonate is mixed with 60 milliliters of a 0.3 molar silver nitrate solution as depicted via the following reaction. So we have 1 ammonium carbonate with 2 silver nitrate gives us 2 ammonium nitrates and silver carbonate. The problem wants us to find how many grams of precipitate are produced, which is the silver carbonate, and what is the concentration of each of the ions in solution after the reaction is complete. Here I've just summarized the information that the problem gave us and what we're trying to find for part A. Since they give us the starting amounts for both of the reactants, we need to determine which one of these is the limiting reactant. The limiting reactant will determine the moles we use to find the grams of silver carbonate. So our plan for this problem is going to be first we find the moles of ammonium carbonate and silver nitrate. Then we use stoichiometry to find the moles of silver carbonate. We determine which one of these is the limiting reactant based on which has the smaller number of moles. And finally, we convert the moles of silver carbonate to grams of silver carbonate. So we need to find moles, and what we're given is volume in milliliters and a molarity. Now remember that the formula for molarity is equal to moles divided by liters. So we can use this formula and plug in our values of what we're given and solve for moles. First, let's start by converting the milliliters into liters, since that's the unit that our formula uses. So we'll start with ammonium carbonate. So we have 50 milliliters, and we want 1 milliliter on the bottom so that the milliliters cancel, and 1 milliliter is equal to 1 times 10 to the minus 3 liters. So the milliliters cancel, and we get 0.050 liters. Now we can plug our values into our formula. So the molarity is 0.250 molar equals X moles, because that's the value we're trying to find, and the liters is 0.050 liters. Now we just rearrange this equation and solve for X. So X is equal to 0.250 molar times 0.050 liters, and that's going to give us 0.0125 moles of ammonium carbonate. So now let's do silver nitrate. So we have 60 milliliters. Once again, we want 1 milliliter on the bottom, and that's equal to 1 times 10 to the minus 3 liters. The milliliters cancel, and we get 0.060 liters. So we set up the equation again. This time we have 0.300 molar is equal to X moles divided by 0.060 liters. So X mole is equal to 0.300 molar times 0.060 liters. And that's going to give us 0.0118 moles of silver nitrate. Now that we have the moles of ammonium carbonate and the moles of silver nitrate, we can find the moles of silver carbonate. To do this, we use the stoichiometry, which is given to us by the chemical equation, and that helps us set up a molar ratio. So the chemical equation is telling us that 1 mole of ammonium carbonate makes 1 mole of silver carbonate, and that 2 moles of silver nitrate are needed to make 1 mole of silver carbonate. So we're going to put the moles of ammonium carbonate on the bottom, since we're trying to cancel the moles of ammonium carbonate. And then 1 mole of silver carbonate on top. And this right here is called the molar ratio. So the moles of ammonium carbonate cancel, and we're left with 0.0125 moles of silver carbonate. So this is how many moles we can make if we start off with 0.0125 moles of ammonium carbonate. So now let's see how many moles we have if we start off with 0.018 moles of silver nitrate. So once again, we set up our mole ratio, we have 2 moles of silver nitrate on the bottom and 1 mole of silver carbonate on top. The moles of silver nitrate cancel. You multiply the top, divide by the bottom, and you get 0.009 moles of silver carbonate. So if we start off with 0.0118 moles of silver nitrate, we only end up with 0.009 moles of silver carbonate. Since silver nitrate gives us a smaller number of moles of silver carbonate, that means that silver nitrate is our limiting reactant. So this is the moles that we use to find the moles of silver carbonate. So now that we know which moles to use, we can find the grams of silver carbonate. So step 4. We have 0.009 moles, and we use the molar mass of silver carbonate to do this. So the molar mass is 275.75 grams per mole. So we want grams on the top and moles on the bottom so the moles can cancel. So 275.75 grams in 1 mole, and that's going to give us 2.482 grams of silver carbonate. So this is the answer for part A.
Hey guys, this is Meghna. I'm going to go over part B of the problem, where we're going to find the concentration of each of the ions in solution after the reaction has gone to completion. First of all, let's review that ions can only come from aqueous compounds that can break apart in water. So ammonium carbonate, silver nitrate, and ammonium nitrate are all capable of forming ions, but there will be no ions coming from silver carbonate since it is a solid and won't break apart in water. Also, as a review from the previous part, we know that silver nitrate is a limiting reactant, meaning that all of this will be used in the reaction, meaning there will be none of their ions in the solution. But we do know that ammonium carbonate is in excess, meaning some of those ions will be left over unreacted in the solution of the products. So the compounds in solution that will be left over are ammonium carbonate, which is the reactant that was in excess, and ammonium nitrate, which of course is one of the products, so it will therefore be in solution. Now we have to remember the ions that will come from these two compounds. Ammonium carbonate will yield ammonium ions and carbonate ions, and ammonium nitrate will yield also ammonium ions and nitrate ions. We also have to make sure when we're calculating the concentrations of the ammonium ions that we take into account the ions from both of these compounds, which I will show you later. First, let's find the concentration of the carbonate ion from the reactant in excess ammonium carbonate. We know at the start of the reaction there are 0.0125 moles of ammonium carbonate, and we need to figure out how much was used up. So we can kind of do the same thing we did to find out how many of the precipitate was made by going in the reverse direction. So we know that 0.009 moles of silver carbonate was made, and now to figure out how much ammonium carbonate was used, we do the same conversion with the molar ratio. In this case, it is a 1-to-1 ratio of ammonium carbonate and silver carbonate. So therefore, 0.009 moles of ammonium carbonate was used in the reaction. Then we subtract how many moles of the ammonium carbonate was put in minus what was used up to find that 0.0035 moles of ammonium carbonate is left over in solution. Now we need to find the concentration of the carbonate ion from 0.0035 moles. To find the concentration of the carbonate ion, it's much the same as finding the concentration of the product. You need to find the molar ratio of the ion to the compound, which in this case there's only one carbonate ion to the whole compound, so it's just a 1-to-1 ratio, which means there are 0.0035 moles of the carbonate ion. Now we can find the molarity of the carbonate ion by dividing the moles by the liters of solution, which results in a concentration of 0.032 molarity of carbonate. Now let's find the concentration of the nitrate ion from the product ammonium nitrate. First, we need to go through the same process and figure out how much of the ammonium nitrate was formed. And we just use the limiting reactant, the silver nitrate, and the molar ratio, which in this case is a 2-to-2 ratio, which is just a 1-to-1 ratio. And we find that the 0.018 moles of ammonium nitrate was formed. Again, to find the moles of the nitrate ion, we take the molar ratio of the ion to the compound, which in this case there's only one nitrate ion in the whole compound, so it's a 1-to-1 ratio. So there are 0.018 moles of the nitrate ion in solution. Again, to find the concentration, all we do is divide by the liters of solution, and we find that the concentration is 0.16 molars of nitrate ion. To find the concentration of the ammonium ions is a little trickier because we need to take into account both ammonium carbonate from the excess reactant and the product ammonium nitrate. So let's start with ammonium carbonate. We already know that there are 0.0035 moles of ammonium carbonate left over, and to find the moles of ammonium from ammonium carbonate, we just need to do a simple molar ratio conversion. We just need to remember that there are 2 moles of ammonium ion in 1 mole of ammonium carbonate, so that leaves us with 0.007 moles of ammonium from ammonium carbonate. Doing the same thing with ammonium nitrate, we find that there are 0.018 moles of ammonium ion and ammonium nitrate. Now we just add up both of the moles from ammonium carbonate and ammonium nitrate, and we get a total of 0.025 moles. Then we divide by the liters of solution to find the final concentration of ammonium ions, which is 0.23 molars. With that, you are done solving the problem.